Hi y'all, in this lesson we are completing the square. So we're learning our fourth method of solving. And this is what the front of Notes 28 looks like, but we're actually going to do that at the end. So go ahead and turn to the inside of yours. You should see 3 examples. We're going to think through all of them sort of at the same time so we can see how each one works. So the first thing that it asks us to do is to solve by factoring. So I'm going to use factoring to solve here. So I know that in order to solve, it needs to be equal to 0. So I'm going to subtract that 3 to the other side. So really, I'm going to be using x squared plus 2x minus 3 equals 0. So for factoring, I know that negative 3 is what I'm multiplying to get. I'm adding to get 2. So I'm going to use 3 and negative 1. So that I would have x plus 3 and x minus 1 equals 0. From there I can pull out that x should be equal to negative 3 and x should be equal to 1. So I have those as my 2 solutions. So that makes sense to me. I'm going to take a look at this one here to see if I can factor this one, because we're going to solve these simultaneously. So for this one here, I can see that it's already equal to 0. So in order to do my factor, I'm going to do negative 3 times 2, and that gives me negative 6. I know that I'm going to add to get negative 5, because that's my b term. So I could use 6, negative 6, and 1, right? So that's what I'm going to split the negative 5 term into, because there is a number in front of x squared this time. So I have 2x squareds. I'm going to split the negative 5x into negative 6x plus 1x. And I'm bringing down the negative 3 so that I can factor out a GCF here. So what's common here is 2x. Left over would be x minus 3. And there's not really anything in common between positive 1 and negative 3. So I'm just going to take out a 1. And that's going to leave me with x minus 3. That's still equal to 0. So I have here, I see my common terms are here. I'm going to take that out to the front. And then what's left over, 2x plus 1. So I have 2 x's plus 1 equals 0. So I know from there I need to solve them. And the first one's really easy to solve. I can just switch the sign. So x should be equal to 3. But in this one, I have to do a little bit more finagling. You might be able to do this in your head. 2x plus 1 equals 0. Subtract 1 on each side. I get 2x equals negative 1. Divide by 2. Divide by 2. X equals negative 1/2. So I know that my answers for the second one are x equals 3 and x equals 1/2. So I have 2 fairly straightforward examples of how I can use factoring. We know we can solve these, and we'll use it to prove that this works. So let's look at the last one. In this one, I'm going to use this green color here, 3 times negative 12. So I'm looking for a number that multiplies to get negative 36 and adds to get negative 11. So I'm thinking of numbers that multiply to get 36. I've got 1 and 36. That's not close enough. 2 times 18. That's not close enough. 3 times 12. If I subtract, that would get 9. Or add, get 15. 4 times 9. 4 and 9 don't make 11. 5 times nothing. 6 times 6. 6 and 6 don't make 11. So I can see that nothing works here, right? There's no numbers that I could factor to multiply to get 36 and add to get negative 11. So what we would call this is unfactorable. So we need a different way of solving this because we're not going to be able to solve it using factoring. So that's what we're going to be working on today. We'll go ahead and check our answers just to make sure that they match with our solutions on a graph. So I'll go ahead and graph this one here. You can graph it on your yellow calculator. I'm going to be using Desmos today. See if we can pull up Desmos here. All right, so I'll pull up this one. and then see if we can pull up Desmos into the corner here. All right, so we're graphing the first one would be x squared plus 2x minus 3, and we can see those graphs there. So when I'm sketching, the super important points are always the y-intercepts, the x-intercept, and the vertex. So in this graph here, I would graph -3, whoops, -3, +1, 0, -3, vertex, and 1, -4. All right, I know just symmetry, that one goes up like that, and this one's gonna go out here. When they say the word sketch, sketch just means you have to include the important pieces, the y-intercepts, the x-intercepts, and the vertex. So if I'm going to look at my points here, I see that my solutions where it touches the x-axis are indeed -3 and 1, which is exactly what I saw here. So we can see that those are verified. We can do the same thing here by graphing this one. So instead of this, we could do 2x squared minus 5x minus 3. And again, I'm going to sketch, so I want my x-intercepts at -0.5 or -1/2 at 3. Have my y-intercept at -3 and my vertex at 1.25, -6.1.25. So I'm just going to graph it somewhere in there. Doesn't have to be too perfect. And then go ahead and graph this up this direction, like that. Again, I'm drawing a sketch here. This is not like a perfect graph. That's not what you want your graph to look like if you're graphing it on a test. But if you're drawing a sketch, or if something asks you to draw a sketch, it doesn't have to be perfect. So we can see our x's are -1/2 and 3. So we can see, again, they verify with the answers that we got from factoring. Of course, on this last one, we didn't have factoring. So this is going to be the first time that we see a solution for this. So I'm going to graph 3x squared minus 11x minus 12. And I can see this kind of funky looking graph here. It's super long, so even like my vertex is at -22, not on my graph. My y-intercept's at -12, so I could even like put a point here. And then they tell me these x-intercepts here, -0.88 and 4.546. So when I graph that, like that's somewhere like close to -1, but not quite on it. And then about halfway between 4 and 5. Something like this. And we know our line just kind of goes down this way and then down this way as well. So it's a little bit harder to graph a sketch of that one since it goes so far off the graph. So we just sort of see something that looks like that, know what's going in that general direction, but most importantly, we have this factor here, which tells us what our solutions are. So that is the beginning. That is factoring and graphing, and both of those are like, okay, factoring works if it's a factorable problem. Graphing works if you have a graphing calculator. But I know some people have been wondering about like what to do if you don't have a calculator. So today is today's that day. We're going to learn something called completing the square. So completing the square, I'm going to go ahead and write down my problem in each section.